Hello everyone, happy Monday and welcome to the AWS Nordics Office Hours. With me, Gunnar Grosch. This week, I am joined by Kamil Bogac to talk about customizing at the edge with Amazon CloudFront functions. And this, as you know, is our weekly show where we bring on experts to talk about a specific topic and let you learn something new and hopefully get your questions answered. So, welcome to the show, Kamil.
Hey Gunnar, thanks for having me.
So to start things off, tell people a bit about yourself.
Sure, absolutely. Hi guys, my name is Kamil. I'm a solution architect here at AWS, and I'm specializing in edge services. So this is my primary area that I look after, working with customers, trying to help them out, understand what those services are, how to work with them, how to incorporate them into their environments, into their workload, and follow the best practices around those.
Right. So I already mentioned the topic, customizing at the edge with Amazon CloudFront functions. And if you have any questions throughout the stream, just post them in the chat and we'll do our best to answer them. And don't worry if we don't get to your question straight away. We try to put the questions in where it is most relevant. So to start things off then, Kamil, let's start to talk about Amazon CloudFront. What is that service?
Sure. Let's draw a bigger picture here, right? What CloudFront is, what edge services really are, right? So I think when we think about developing application in AWS, first our thoughts goes to AWS regions, right? This is where you'd usually build the brain of your application. This is where you would have all your data store, your business logic with containers, right? A bunch of EC2 instances, RDS, and so on. So that's where the brain of your application is. And you decide to which of those 25 regions you'd like to go and build that application. And that's the core, right? However, if you go further, right, that's not entirety of AWS infrastructure, because on top of that, we also build so-called edge locations, sometimes refer to them as POPs, point of presence. And in those edge locations, this is where CloudFront lives and other edge services as well, right? So the whole idea is that we build this distributed network, distributed infrastructure, where we host edge services such as Amazon CloudFront, AWS Global Accelerator, AWS WAF, AWS Shield. And the overarching goal for those services is to accelerate the delivery of your workload. So to accelerate the delivery of the content from the brain of your application, from regions, as an example, to your end viewers on the other end of the chain, right? So yes, Amazon CloudFront, AWS and AWS Global Accelerator serve that purpose to accelerate that. It happens through a number of mechanisms that I guess we talk about as well. And the second overarching theme that I also want to bring up is not the subject of this call, but still is AWS WAF and AWS Shield. So those services from what we call perimeter protection portfolio of services, and their goal is to safeguard your application from any type of DDoS type of attacks, application vulnerabilities, and so on. They're also there to build up this protection at the front layer of your application, at the front door of your application.
But why does it matter what the latency is, or to speed up that delivery? Does it matter if it's single-digit milliseconds to deliver something, or if it's 200 milliseconds or 400 milliseconds?
Oh yeah, absolutely. And there's strong incentives coming from, when we talk to customers, there's strong incentive coming from the business to improve that performance, right? Understand in such way, right? So if you run e-commerce site as an example, right? The faster your page load, the quicker the viewers can see your products, right? The quicker they can navigate through the website. This has direct impact on the conversion rates and how customers interact with your website, right? If your performance is not stable, if your performance is not good, you'll see viewers churn, leaving your website. And nowadays online users are really impatient, right? And if your website takes even 1-2 seconds to load up, they may already leave your page. So that's one aspect of it. But the second aspect of it is that if you really want to operate at global scale, right, you need to have that sort of capacity, right, across the board, right? Because a lot of our customers run their businesses in different geographies, right? And whereas the region, they pick the region in 1 or 2 places. So to have that extended outreach, right, you want to put your content closer to your viewers. So you have also access to all of that capacity. that edge distributed network provides, because those edge locations, we put them in very strategic places where we have access to the local carrier networks in a given geography.
And talking about the global infrastructure of AWS, we have, I think it's 25 regions to date. 7 or so new regions have been announced, not yet up and running. How many edge locations do we have, or points of presence?
Yeah, that's a good question. So actually, I can maybe visualize that very quickly. Yes, as you said, 25 regions that we have today with 81 availability zone. And every time I'm making presentation about it, I need to go to our infrastructure page and verify the numbers are still up to date, because we keep adding them so fast. So currently we are at over 225 points of presence globally, across all the continents, as you can see. And also, note from, I hope you get that from that slide, is that those POPs, they are not also like disconnected islands, but they're also connected to the backbone of AWS network. So it's not only about having being in close proximity in the last mile, but also when the traffic goes from CloudFront to your region, it runs over our AWS private backbone. So this really isolates your workloads from those common instabilities in the internet ecosystem.
Right. So we get a hello from John from Melbourne in AP Southeast 2, at least. So hey, John, welcome to the show.
We definitely have pubs nearby.
We do. All right. So this is the Amazon Global Network. And next then, where do we go from here? Talking about CloudFront and edge locations.
Yeah, very, very good question. So, CloudFront, so the way the CloudFront works at principle, so CloudFront, let's explain what CloudFront is, right? So it's AWS content delivery network. And what content delivery network does at its core is it caches your content. It brings the cacheable content you have in your application. CloudFront stores that content, caches that content. So when the viewers comes in, then they don't have to go all the way back to your region, but that content is being served directly from the edge location. And there's some other native features of CDNs as well. So it allows you to operate also in like multi-origin scenarios. It allows you to present customers, say, with the custom error pages if your origin is unavailable. So there's a bunch of native features that you can use to increase not only performance, but availability perceived by the end users. So you have a bunch of those native features that are used commonly across the board by our customers. But then almost each of our customers has some sort of unique requirements. Their use cases are unique in a way, right? And for those unique cases and their needs, they were always keen, to take advantage of that global infrastructure we have, and take some of the functionalities they would run at the origin, sort of decouple them and run them closer to their viewers to further increase the performance, but also to offload your origins from those things that can be decoupled from origin and run on a global scale.
Because what we perhaps first think of when we talk about having things at the edge closer to the user, it is the typical static content, images, getting those closer to users. But now we're talking about compute closer to the users, right?
Yes, and very often this is very, very first thought that pops to your mind when starting CDN, that is unrelated to static content. But it also works very well for dynamic content as well, right? And this is something that a lot of our customers get to realize as they start working using CloudFront more fully across their workloads, is that it's not only about caching, but also the fact that we use global network, we use bunch of network and transport protocol optimizations, right, with regards to HTTP2, TLS, TCP, and all those boring details, right? But there's a lot of work. Actually, there's so much you can do on that layer to further accelerate your workloads, and this is what we take care of also with CloudFront, right? And so you would see actually pretty nice performance gains for dynamic workloads as well. And there's also, I encourage you to have a look in the reInvent talks from Tinder, who talk about how using CloudFront improve their API workloads.
Yeah, and I guess API is a very common use case that we're seeing, that people use API gateway and then use that dynamic content out of API gateway through their edge locations.
Great example, API gateway. This could be ALB as well, right? Any kind of HTTP-enabled service, right? So it doesn't really matter on which service you host that, right? But what CloudFront is going to do is also, maintain persistent connection to that, right? So there's a lot of signaling going on between normally when you establish a new session, right? When you open up your application and there's a TCP handshake, there's TLS negotiation process. There's a lot of back and forth to establish that connection before you actually start exchanging any data, any meaningful data for your application. So what CloudFront is doing, so from those edge location, edge hosts, we maintain those so-called persistent connection, TCP connection. So they're open, right? So once you make first request, it's open for the subsequent request. So when the new user comes in to the same POP, the TCP connection is already there. It's warmed up, so you go straight to your origin with a lot of that back and forth that you would normally see if you didn't have edge. If you didn't use CloudFront.
Right. We're 11, almost 12 minutes into the stream, and we're talking about Amazon CloudFront moving into Amazon CloudFront Functions, which is the title of the show. And people are getting anxious. They want to know more about CloudFront Functions, I think. We've got a question from Pabudu in the chat. Can you explain the different use cases for Lambda at Edge versus the new CloudFront Functions? So
yeah,
we need to get there, Camille.
All right. So yeah, let's get focused on that. So first of all, good. I see Lambda. That's already brought up. So yeah, let's start here, right? So as I already talked about, so customers very often have their unique case, and they like to put some of the functionalities from the origins to the edge. And this is where we brought Lambda at the edge at first into play years ago. And so what I'm explaining here, applies both for Lambda at edge and CloudFront Function. Which is, how that edge compute integration of CloudFront looks like. So as if you're familiar with Lambda, you know that when you're on Lambda, you run your function in response to certain triggers. This could be like you upload your file to S3, and that triggers Lambda function to do something with that. You provide context behind that event, and you do whatever is necessary in your logic. It's no different with CloudFront and its integration with Lambda at Edge. So you also define your logic within Lambda, if you're talking about Lambda at Edge. And there are 4 triggers in the scope of CloudFront Functions that can trigger your function. And there are specific in the context of requests flowing in and out between the viewer and your origin, passing through CloudFront in and out. So the first trigger that you can attach your function to your code to is your request event. So this will be triggered on all the requests hitting your CloudFront distribution. So that means there's important call out and takeaway that as we start talking about triggers, that viewer request events, they will be invoked on 100% of the requests coming in, and they will be also triggered before that request start going through those layers of caching, right? So very often the use cases around those concern like attributes normalization, what's in the header, URL. It could be viewer authorization as well, like checking JWT token, if it's valid or not, and if not, present customers with error code, as an example. So you have that, and moving on, we have origin request event. And here's the important distinction between this one and the previous one, is that this one, origin request event, will be only triggered on so-called cache misses. So when request comes in and asks for an object which is not in cache, that's what we call cache miss. And from that point onwards, that request would go forward to the origin. So this is where origin request trigger would be invoked, and you can also associate your code with that. And you can apply your custom logic here as well. And common use case here would be some advanced routing mechanisms. So if you are in this multi-origin setup, right, you can also integrate with some other services such as DynamoDB, and there are a lot of cool references about that to see if this request with this URL, with those set of headers, then I should go to this origin, or maybe I should return redirect and send it back to the user. So very often customers here, they would also render the response instead of going to origin, such as redirect, right? That's a very good example. This is a very simple response that you're able to calculate, compute at the edge. Origin request event is a perfect place to do that, because once you create that response, you can put that to cache, and all the subsequent viewers will get that cache response coming from Lambda Edge, really. And then we move forward. So we have similar type of events on when the response goes back to the viewer. So origin response event, where you also have access to the response attributes such as HTTP headers, status code from your origin, and you can also act based on those, right? So very nice reference architecture, which also have in the blog post, is with image optimizer, right? Where CloudFront can opportunistically make a request for image of certain format, of certain rendition. And if you have origin returns for status code saying this object doesn't exist, you can intercept that with origin response event and actually create the one with the specific format and the resolution that you intended to in the first place. And a very common use case here would be also adding certain headers, such as course headers, security headers, that instruct your browser, how to interact with your content. And viewer response events is very similar to it as well, with the distinction, this happens after the cache, right? So you can also here, it also makes sense to return individualized responses, such as setting the cookies based what was in the request. Okay, so that's on a very high level, what kind of triggers we have for our edge compute options. And now, what we kept hearing about Lambda Edge, right? So especially for the viewer-facing function, which I talk about, that are being executed on 100% of the requests, view response, view request, as opposed to the origin-facing triggers. So first of all, there was some notable performance impacts when you run a view request or view response, because while we run those functions closest to the viewer, Lambda Edge is being triggered at the regional edge cache layer. So that's the second tier of caching in that sense. So when you have this very short-lived function, you do something simple, such as you modify URL, right, on a fly. Actually, those additional milliseconds that are being added by Lambda Edge actually are being notable in the overall latency that your user perceive. So there's that. Also, as with any Lambda workloads you run, there's some limits to it, right? So we talk about concurrency limit. There's also like RPS, request per second type of limits, and burst limit. So how quickly you can scale the traffic that invokes your Lambda function. So you really had to do a little bit of, actually a lot of math when you were dealing with Lambda Edge and your request function to make sure that you scale that properly in setting your concurrency limits, because it works on all those 3 dimensions. So you need to make sure your burst limit, concurrency limit, and request per second limits are intact. So you make sure so that you don't run into some throttling type of situations. And for customers doing very simple things, that was a bit of overhead for them as well. Then there's also a part of the cost. So customers, using Lambda Edge on your facing function on every single request coming through, you will see that on your bill as well. And lastly, but as is so better developer experience. So if you ever dealt with Lambda and the Lambda workloads, right? You know how the Lambda console works, right? And there's a little bit of a setup you need to do to get this running. Like you need to set the permission for the IAM role for that Lambda Edge functions. And there's a number of steps and processing to go through to enable that on your CloudFront distributions. So we took that feedback, and this is where we introduced CloudFront function not long time ago to address all those points that has been raised by our customers. And so let's analyze very quickly what are the benefits of using CloudFront function and how they compare to Lambda Edge. So first and foremost, CloudFront function has been designed to act to operate with a great performance. So all that performance impact that we talk about, so you would see those additional milliseconds in your workload. With CloudFront functions, if you run your workload with and without CloudFront function, you shouldn't basically see any difference. It should be sub-millisecond latency, and as such, you shouldn't see any impact. Also, all those scaling factors that we just discussed, right? Concurrency, requests per second, so on, they're no longer the case with CloudFront function. So it is designed to follow the scale at which you operate CloudFront. So if you're running millions of requests in different geographic area, doesn't matter. CloudFront function is just going to follow that scale, and there's no limits like scale-wise attached to CloudFront functions. It's also very cost-effective. Milo is not focused on that, but it's basically at 1/6 of the price of typical Lambda Edge workloads with your requests. And something we will also have a look through a demo is we really redesigned the developer experience to make that much more simpler for those lightweight use cases where you want to get those running very quickly and without those additional steps that you have to go through with Lambda Edge. We took a lot of attention to streamline that process. However, without sacrificing, any of the good developer practices, as a stage rollout process going from dev to live and so on. And we look in a minute how it works. And last but not least, obviously, security is a job zero here at AWS, and we also made sure that the process level isolation that CloudFront function operates now meets all of our security standards, similar to Lambda Edge or Lambda workloads where you have virtual environment type of isolation as well.
So, Camille, I think you have an image showing the difference more clearly between Lambda Edge and CloudFront functions. Let's bring that up and let's just compare the two to answer the question we got.
Yeah, absolutely. So let me just skip through. So first, on a very high level, right, if you think about the use cases for CloudFront functions versus Lambda Edge, so CloudFront functions are meant for those lightweight, short-lived functions, and you see how is that reflected in the characteristic of that new runtime. So whenever you think about modifying your request on response on the fly by changing, say, URL, by doing URL rewriting, doing redirects, right? These are those very short-lived functions and very simple use cases that CloudFront function will be perfect fit on. Then you also, there are certain libraries also included in that runtime, such as crypto. So you can also perform operations, viewer authorization activities as well. So if your viewer presented himself with a JWT token, you can also verify that and allow him in, or drop that request. And however, Lambda Edge is still out there, right? And there's a number of valid use cases that would still look into Lambda Edge instead of CloudFront functions. And here we're talking about all those scenarios where you need these long-lived functions to execute, say, external network calls, or using external libraries to do much more compute-intense operations, such as server-side rendering. So if you compute and render your response using Lambda Edge, right, this is where you would most likely like to use some external data sources to do so, and you would need much more compute to do so as well. Also modifying the payload of the report, such as string manifest manipulation, where you would get original object, look what's in the payload of that, modify that, and only then return that. There's multiple steps in that process, and this is where Lambda Edge still thrive in addressing those use cases.
So I think the text in is it yellow or is it orange is really important here, that Lambda Edge and CloudFront functions are meant to coexist. CloudFront function doesn't replace Lambda Edge, but some of the things that we previously did with Lambda Edge should now perhaps instead be done by CloudFront functions.
Yeah, that's exactly, and that's a great summary, because fundamentally, I think this follows our philosophy here at AWS, which is having the right tool for the job. So if you think about other domains, such as compute, containers, right? You look at them, and you'd very often see that we have those general purpose tool, where you have full control over what's going on. You have this variety of options, and you can apply them for pretty much any use case you have. But then the next level of evolution is that we create those more targeted, tailor-made services for specific use case, which are great for practitioners, right, who don't want to get into all those nitty-gritties, but they want to use those effectively and quickly, right? And I think this follows exactly the same trend.
Yeah.
So yes, with Lambda, that you can address plethora of use cases, and CloudFront Functions, I would say, is a subset of that, where it makes much better fit for some of them.
All right, we're 25 minutes into the stream and we haven't seen the console, or we haven't seen any CLI or any code yet, Camille. I think it's time to jump over to something to give an example of how we can use CloudFront Functions.
Yeah, absolutely. So let's jump into the console straight away. And so yeah, here's the landing page for CloudFront distribution, and now you can see with this flashy new pop-up, we have this new feature for functions. And so this is where you would and as usual, it's getting slow. I run the demo. All right, so there you are. So this is where you define your function. So this is a bit different experience from Lambda Edge, and we will talk about how does it differ. So here's the list of all your functions. As you can probably see, you define your functions outside of your distribution definitions, right? So where you run your CloudFront distributions, specific for your applications, you define functions separately, and then further you would make associate between your specific workloads. So maybe we can actually go through example. So for my website, right, say I want to run A/B kind of testing scenario, right, where I want to say 50% of my users to version A of my website, and then 50% to version B of that website. So let's look how that play. So here I have my function created, and when you navigate to that function page, you'll have multiple of subtabs. So let's go through them. So first one is build up. This is where you have this is where you can define your function and put your code in line, and we can explain what does it do. But you can also see that for your function, you have this live and development stages. So this is a bit of a change to the deployment model that you may be familiar with Lambda at the edge, which works on the principle of you create version 1, version 2, version 3, and they can stack up. And in Lambda at edge world, you associate specific version to your CloudFront distribution and cache behavior. Here the approach is a bit different. We have those two stages, development live, and you operate within those. So code in a development stage is where you can basically play with it, do all the testing. Any code at this stage will never run in production. This is where you basically experiment with that, making sure that it works as it's supposed to be. And I'll show you in a minute how you can how you can test that. And then you have live stage. So once you promote your function from development to live, this is where you lock in whatever you created. So as you can see in this, you can see what's your live, what's your code in your live stage, and you can see it's gray out, it's blocked from any addition. This is the code that will run in production. So as you move from development live, make sure you do your ORIOL tests and you're confident with the function that you're deploying. And very nice thing about that is also that how you can very easily test your function. So just to give you a little of a glimpse what I'm doing here. So looking into my code. So in my A/B testing approach, what I'm doing here, I'm checking for cookie existence. And if the specific cookie exists, I will send user either to version A and B. So I'm rolling the dice. At first, you would roll the dice. And you would apply the right cookie for version A and B. And when you log in the next time, you're checking if this cookie is present, what's the value of that, and based on that, you send the viewer to the right version of the page. When I say send viewer to the right version of the page, that basically means you change URL on the fly. So you take the URI and you change to site, as you can see, site B or site B, depending what that user segment value turns out to be. So that's on a very high level what this function does. And if you go to the test page, this is actually very nice, and you have very nice user interface to test your function. So as you can see here, you can simulate what your function is going to do when the request hits with specific attributes. So here in a safe sandbox almost environment, right, my function in the development stage, I can define my viewer request. What would that be? And say this is going to be get request. This is going to be get request against, say, root page in that case, coming from this specific IP. And here you can modify all sort of parameters about that request. So you can add request headers, you can add request cookies, query strings, right? And then see what would be the result and how the response of your function would differ as you modify those, right? Obviously, you can define your test cases here to your liking.
So with the example you had right now, you could test it first as an initial request and then with the cookie added as well.
Exactly. So like here you can see, and also you can see if you log in something in your function, you can see those logs, right? And you can see here, I rolled the dice, and the result of rolling the dice was 22, and that would determine that in that case, the URI was changed from root directory to site A index A. So I'm landing on the version A of that website. And also, very nice thing is here that you can see in compute utilization where you are within the function. I will speak about those later on. But basically with the time allocated for your function to run, you can see if you use 30% of the time allocated to run your function.
And you'll get back to that, you said.
Yes, exactly.
Yep.
So this is basically, so this is how you can be your confidence in that. Okay, what you have in your development stage is working properly. You run your test, and then you move to the next stage, which is, hey, let's publish this function. It's very simple. You just click publish, and what does it do is exactly what I show here. It's just going to copy paste what was in your development stage, move it in live, and lock it in. And only function at the live stage, what's in the live stage, can be associated with your CloudFront configuration, with your CloudFront distribution, which is the last step of the process. So you have your function published in the live stage. So now you want to see it in action. Here you can choose your specific CloudFront distributions. So CloudFront distribution map to your specific web application. And you choose the triggers, so the ones that we spoke about. So that's one caveat about CloudFront function. It only operates with viewer requests or viewer response triggers. Origin-facing triggers are still reserved for Lambda Edge. So I'm going to attach it on the viewer request. You choose the behavior. So maybe let's explain that behavior is basically a path pattern, URL path pattern that this viewer request will be attached to. And
it's fetching this from the distribution you selected.
Exactly. So I choose simple website. If I had more cache behaviors defined, all of them would appear in that dropdown, and you can select all of them. So some last prompt, and there you go. And you see that here. So now also, so this is also very nice change when it comes to CloudFront function, is that from a single place you can associate your function with multiple distributions. So if you have multiple application and you have say common register of functions that you want to run for different application, you define that only once and you make association to different functions. And when you make changes, right, you do something in development stage, you push that to live. those changes as you move it from them to live will be automatically propagated and applied across all those distributions instantly. Whereas with Lambda Edge, it's more of a multi-step process where you need to go to each distribution and make change on each of them, updating the version of the Lambda that associated that. So with that regards, this is more streamlined experience as well. So there it is. So I have my functions associated with my CloudFront distributions. Now we can see it working. So let me pick CloudFront's domain name. So this is the dedicated CloudFront domain name that you get once you spin up your CloudFront distributions associated with your application, and it's entry point for your application. And there you go. I'm being steered to the version A of my website. With a very friendly face on it. And you can see why that happened. You should also see why that happened. Okay, so I have cookie set here. Okay, so sorry, one thing I also didn't do. So if I now go along with this, actually, if I remove the cookie, because we haven't set that yet, I keep on refreshing this website. I'm being switched between one the other one. So what I'm lacking here is also the session stickiness, right? Because if you want to run this canary deployment on A/B sort of testing, you don't want your single viewer to constantly switch between one version or the other. You would like to have that stickiness. So you made that decision once, and then you stick to it for the subsequent requests. So this is where we can add second function. So let's switch back to my functions page. And then I have the other one, which I intend to associate with my view response trigger. So what I did in my initial code, when I roll the dice for the new viewers, for a new viewer saying, okay, this user segment value is below 50 or above 50, I put that as a custom header on a viewer request, and on viewer response, I can read that custom header that was set on a previous function. So there's this inner communication between the function using those headers. So if that header is present, I'm taking the value that present of that header, and I set that as a cookie in here. And I follow exactly the same process. We can skip the testing phase, very simple function. Let's have that publish. And again,
skipping testing only in demo mode, right?
Exactly. I would never do that in production. You should always test your function.
Yes.
Let's make sure I pick the right function though. So viewer response. So when the response is leaving CloudFront cache, same behavior. And there you go. The association is added. It's also confirmed here. So let's see how would that work now. It's going to probably take a few seconds, maybe minutes, to propagate that change. So you see that, but at some point, you could see I previously cleared my cookie, but you would see that this cookie is being set in the response. Oh, there it is. So you can see the cookie is set to 16, and in my split, which is half and half, the cookie value lower than 50 would go to version A, where above 50 would go to version B. So let's say I override my cookie now to the value that should bring me to the version B of my website, and there you have it. You're on the second version of that. So this is how you can run your A/B testing, but it can also come very useful in your canary deployments, right? Where you roll out a change, and you want to start small. You want to take a baby step and say 5%, maybe for your mobile users only, and see if that works. And if everything works correctly, you just move progressively. You move more traffic share on that new version of the page. So let's do that, what I just described, and let's modify my initial function, the function that I attached to the viewer request trigger, which decides on which version you're going to land. And let's modify what I did here a little bit. So here you can see I have this logic which checks what's the user segment value, and based on that, it will send you to version A or B of your website. If I just comment that out. Now there's, I also enrich that logic here a little bit, the part I'm just uncommented on, where you can take advantage of CloudFront generated headers. So all the headers that come from the viewers are available with CloudFront functions, but there are also some other headers that CloudFront can generate and that you would have access with CloudFront functions. And that's also very nice nuance about CloudFront functions as compared to Lambda Edge. So all those CloudFront generated headers, which regarding device characterization, viewer characterizations, they wouldn't be available until origin request trigger in Lambda Edge world. With CloudFront functions, you actually have access to them on viewer request or viewer response triggers as well. So you can also take advantage of that here. So what I'm doing here, I'm checking for one of the CloudFront generated headers, which is CloudFront is mobile viewer. It's a very simple header that can assume one of two values, true or false. And if it's true, then that means that request is coming from the mobile viewers. There are similar headers as this, which can tell you, like Boolean headers that can tell you if you're coming from a desktop type of device, if you're coming from tablet, and so on. So what I'm doing here, I'm checking for existence. So here I want to limit my A/B testing only for mobile devices, right? So for desktop users, I won't keep them on my default version of my application. And for the mobile viewers, I want to send 20% of them to the version B of my website in this case, which is exactly what I'm doing here. All right, so let's save that. Again, very bad practice not to test your code. Update your code, and just maybe to confirm that this actually moved that to live stage. So yeah, you can see that the part of the code I uncommented is now is reflected here. And that's it. You don't have to do anything now with regards to association because that association already exists. So you only do that once. When you create your function at the first pass, and later on it just comes out to publishing your code, and those changes should be automatically propagated.
All right, so that just proves that it's even more important to do the testing phase, perhaps when moving from development to live. Yeah,
and then see how would that work, right? So using I can switch to the mobile version using the developer tools here. So let's remove the cookie value I had before. My page is so not well formatted for the mobile devices. But anyway, so you can see I was now, again, giving some value. So it was below 80. So this is why I'm on the serial version A of my website. But if I was in this 20%, the viewers who would get statistically higher value than 80, then there you go. You're on version B of that website.
Yep.
And if I toggle back, and I'm here as again as a desktop viewer, then I'm always gonna end up on the version A. So this is one of the examples how you can do that based on the device characterization. But very common use case for our customers also they would look into geo headers that CloudFront also inserts. So if you're coming from this country, to the extent to even this state, if you're in US or this city, you can really personalize the responses that you would return to the customers.
Cool. And in this case, you had one for request and one for response, two different functions. Otherwise, are there any best practices yet on how you should split it into multiple functions or when to keep things in one function. In this case, you had to split it up, but otherwise.
Yeah, I guess, it depends on the use case, right? I think here it was pretty obvious, right? So you want to set a cookie, so natural place to set a cookie is on the viewer response, right? And you want to set the cookie for every user independently. So you could think, oh, should I do it on origin response versus with Lambda Edge or viewer response? So this is where you need to think about the use case and the flow and the entire flow of the request and the response. So in this case, you want to treat each user differently, right? So this is why you made a decision. Okay, this cookie needs to be set only on the viewer response, right? And you wouldn't do that on a viewer request, obviously, because you want to pass that request further to origin and get the website that you're after, and you would only need that when that response you retrieve from the origin leaves the cache. So you need to think through those use cases. But yeah, I mean, to your point as well, it's also a question of where you should use origin, where you should use CloudFront function versus Lambda at the edge, right? And very often, customer might see the pricing component of that and the fact that's 1/6 of the price, and gravitate towards using CloudFront functions more often. I would say, still you should thought that through, and I would say in the entire thought process or what you should use when, my approach is always, if this is cacheable content with decent cacheability, I always default to thinking, can I do that with origin request, origin response function? Because if you can minimize the number of invocation in your functions, I think that's always win, right? And just serve the cacheable content and only do your logic on cache misses, either with Lambda Edge, any type of use case. So this is the kind of first thing I check on my list when I'm trying to determine which of those I should use. And then, when you determine that, okay, this is maybe not cacheable, this is not cacheable content, or for a specific use case, it needs to be viewer response or viewer request because it needs to be executed on every single request coming in. Then it comes to all the things that we discussed before. Is it a lightweight use case, or this is more complex use case where Lambda Edge would be a better fit? So that's my mental map, how I navigate through that.
Yeah, excellent. All right, so we are 47 minutes into the show, approaching the hour. So if you just joined us, too bad. This is us talking about customizing at the edge with Amazon CloudFront functions. But don't worry, the entire episode will be available on demand afterwards. So, Camille, what should we spend the next 12 minutes on then on the show?
Yeah, so maybe you can also talk a little bit about the characteristics, get into a little bit more details about the characteristic of that new runtime. If you're a developer, I think that might be of your interest as well. So let me switch back very quickly. All right, so let's compare Lambda Edge and CloudFront function, to each other, and what the differences are. So if we start talking about the runtime itself, so with Lambda Edge, you can either use Node.js runtime or Python. With CloudFront functions, for now we're sticking to JavaScript, so plain vanilla JavaScript, ES 5.1 compliant. So that's number one. JavaScript is what you need to stick to. Then, as I already brought up, with Lambda Edge, you have all 4 triggers available that you can attach your function to. With CloudFront functions, you can apply that for view request and view response at the moment. Now the third point is also quite interesting, and this is what has to do with that performance factor that I talked about in the beginning. So with regards to Lambda Edge, we still execute your code if you attach to view request or view response to the closest location possible. But that would be regional edge cache, right? So this is second layer of caching between our edge pops, second tier of caching between our edge pops and your origin. And we have 13 of those around the world. With CloudFront functions, your code is actually being executed across all those 225 edge pops. So when you land on the closest pops to your location, that's where your code will be executed. And this translates into that performance benefit that, again, that we talked about previously. Then with regards to scale, yes, again, CloudFront functions follow the scale of CloudFront. So even if you operate at millions of requests per second, CloudFront function, there's no limit attached to it, period. CloudFront function just scale instantly with that. Whereas for Lambda Edge, if you continue to use that in number of use cases, you should still put all those considerations that we talk about, right? So make sure you keep on tracking, what's your concurrency utilization, that you're well with those limits. If this is a new workload, also engage with your account team, with solution architects, people like myself. And we also do a lot of work in helping our customers to reason about how to think about those limits and how to calculate those. In terms of the function execution time, when we release CloudFront functions and I approach my customers with that new code visual, common feedback I heard from them was, well, we're already running our functions with Lambda Edge, and the execution time is around 5-10 milliseconds. So probably not the best fit for purpose if you think about the function execution limit of CloudFront function, which is less than 1 millisecond. So this is also the other important takeaway, that the function execution time measured with Lambda Edge is not exactly alike with the execution time limit with CloudFront functions. Because with Lambda Edge, this includes all the preceding activities like spinning up your environment, right? The worker which will execute the code, bootstrapping your code, loading that into that worker. So it's all being accounted into that process. In CloudFront function case, when we talk about time execution limits, we're talking solely about the CPU time of the execution. So you'd be actually surprised how much you can do with that 1 millisecond if we talk about CPU execution time only. And we already have a lot of cool prototypes and customers doing really quite complex, even quite complex stuff within those limits. With HMAC verification, also doing some regex and so on, and they're able to feed that within that 1 millisecond limit. The other two are also important, and I think they naturally ties to what we said, that characteristic of Lambda Edge, which is this is designed for short-lived, lightweight functions, right? So I think by that definition, it's pretty natural, and that would also exclude making external network calls. It's rather unlikely you'd manage to make external network calls within that 1 millisecond limit as well. All that also includes file system access. You don't have that with CloudFront functions. CloudFront function logic should be self-contained in that piece of code that you push. And the other, and when you start talking about, and in terms of the maximum function size, it's currently set for CloudFront function as 10 kilobytes, which should be also enough if you think about, and I think it aligns this 1 millisecond limit as well. But if, for whatever reason, that's not enough for you, and you exceed that 10 kilobytes limits, you can think about, all the other approaches to it, when you can use like minifiers, bundlers, and minifiers to compress your code as well. If you have a setup where you use also some lightweight external modules, you can actually squeeze into that 10 kilobytes limit using this sort of tools as well. And last but not least, both of them obviously supports function logging and emits some metrics. And maybe we can talk about those more. But another benefit of using CloudFront function is that it aggregates all the logs coming from the function in a single place. And that was also another thing that came from our customers as a feedback from the developer community, that when you're running functions with Lambda Edge, it will be logged in a CloudWatch under log groups in the nearest region where that function was executed. Right. So if I'm executing my function here from, if I as a viewer coming from London, and my function is being executed with Lambda Edge, you would look that in our London region. Whereas if you did that in Germany, you would look that in Frankfurt region. So it's a bit of a struggle to toggle between those regions as you're trying to troubleshoot and look for specific requests. With CloudFront function, that got much simplified because everything aggregates to US East 1 region regardless of where you execute that function. So you have everything in a single place, which is also a very nice thing.
All right. So you previously skipped over a part in the console, talking about was it the timing of the Lambda function? It showed 71, I think. Should we do a quick look at that before wrapping things up?
Yeah, absolutely. If you switch back, so all the metrics that I'm going to show you that are available in CloudWatch, most of the metrics we emit, but you can also access them from here, from function page. So if I take my URL rewrite, you can just click monitor.
Cloud Crawler is asking if logging is on by default, just like with AWS Lambda.
Yes, it is by default, but you need to explicitly in your code insert console.log for that to be emitted in your log, obviously. But yes, it is on by default. All right, so here you can see, maybe let me just zoom out a little bit. There are a couple of useful things. So first of all, invocations. So you can see, at what scale, how many invocations per minute you have. So you can see the spike as I was running that. And it's also global metrics, so invocations globally. Then you have validation errors. So this is where you should, these are potentially the things that you would also set your alarms on if you're using CloudWatch, right? So if you're talking about validation errors, they shouldn't really appear if you tested your function thoroughly in your development process, because validation errors basically means that your function did something wrong. So as you execute your function, at the end of the execution, it should return valid JSON object, right, that comply with specific format of the event structure. And if, as an example, you return something which doesn't fit that, that would appear as a validation error, right? So obviously, if you see any occurrences of that in this graph, there's something in your code that's doing things wrongly and result in that validation error. Most likely, you return invalid object as a result of your function. And yeah, then execution error, right? So if there's some runtime errors, right, as you execute your code, or also here you would see if you reach the throttling limits and there's some instances of throttling, they would also appear under execution errors as well. So you should also be mindful of that and even set alarms on that. And yeah, there you have compute utilization. So you can see for my simple function, it was very low, and this is expressed in percentages. So it was at the level of 11%. In this view, you only see like average value, but I would definitely encourage you as you run your test at the larger scale to look not only at average values, but P50, P80, P90, right? And if you're seeing that you're getting anywhere close, say like 80, 90%, right, which getting dangerously close to the place where you may experience throttling, you should have a look into that and see, if there's anything you can do with your code to make it more optimized and make sure it stay with that safe zone of compute utilization.
Right. So, Camille, we're at the top of the hour, and we've talked about customizing at the edge with Amazon CloudFront functions, compared it to Lambda at Edge, and talked a bit about, in general, about the Edge and Amazon CloudFront. So any final words, some words of wisdom for people out there wanting to perhaps have a look at CloudFront functions?
Just one, use it as much as you can. As we said, it's all about giving you the right tools for the job, right? So as you think about your workload, see if this is a good fit for your purpose. And obviously, as we rolled out, we're so eager to hear your feedback and see any novel use cases, people using that. So yeah, if you see something, if you have some strong ideas, how you like, what additional features you'd like to see with CloudFront functions, what sort of integrations, reach out to your account teams. We thrive to surface that feedback back to our product team and make sure the CloudFront functions are on the right track, and the further releases would include the features that our customer wants.
All right. And with that, thank you very much, Camille, for joining me today, and thanks everyone for watching. If you have any feedback or if you have any additional questions, follow me and Camille on Twitter. Ask your questions there. And thank you all for watching. See you again next week.
Thank you.